Respected viewers and dear students, अस्सलाम वालेकुम। आज हमारे कोर्स का लेक्चर नंबर 34 है। इससे पहले के लेक्चर में हमने लाइन इंटीग्रल की बात की थी और उसके एंड में हम ग्रीन थ्योरम कर रहे थे। आज हम जो शुरू करेंगे वो ग्रीन थ्योरम से ही शुरू करेंगे। उसकी स्टेटमेंट मैं दोबारा दूंगा आपको और उस पर एक एग्जाम्पल करेंगे। P and Q are functions of x and y which are continuous on the region R, which is bounded by a closed curve C, and the derivative of these function, partial derivatives of these function exist. Then integration of P dx plus Q dy over the closed curve C is equal to minus of double integration of partial derivative of P with respect to y minus partial derivative of Q with respect to x, and this integration is with respect to x and with respect to y over the region R. This region R is bounded by the curve C. I have stated the green theorem, and now an example to apply the green theorem for such functions. Let us do the example. Here we have to find the integral of xy dx plus 2x minus y dy over the closed curve C, which is around the region R, and the equation of this curve is given by y is equal to x square and x is equal to y square. You can see here that P is xy and Q is 2x minus y. So we will apply for this integration the green theorem. For that purpose, we will find the partial derivative of P with respect to y and the partial derivative of Q with respect to x. Before doing so, it is always beneficial to draw the diagram. So let us see the diagram of this closed curve and the region bounded by that curve. Solving these equations for curves, y is equal to x square and x is equal to y square, the point of intersection are 0, 0 and 1, 1. Y is equal to x square, as you know, is the parabola whose axis of symmetry is along the y-axis, and y is equal to square root of x. You can consider it as x is equal to y square. So therefore this will be a parabola whose axis of symmetry will be along x-axis, and you can see in the diagram these both parabolas are meeting at the origin 0, 0 and the point a 1, 1. So we have to integrate our function along this closed curve, and first of all we will transform this integral using green theorem over the region bounded by these curves. So for integration now, first of all P is equal to xy and partial derivative of p with respect to y is x, and now q, which is 2x minus y, and the partial derivative of q with respect to x is equal to 2. So our integral is equal to minus of double integral of x minus 2 with respect to x and with respect to y over the region R. ये देखिए, ये डबल इंटीग्रल है जो कि हम पहले कर चुके हैं, और इसके लिए हम क्या करते थे कि अगर विद रिस्पेक्ट टू y पहले करना है तो एक स्ट्रिप अलोंग द y एक्सिस पैरेलल टू y एक्सिस ड्रॉ करते थे और y की लिमिट्स मालूम करते थे, और फ्रॉम फिगर हम x की लिमिट्स मालूम करते थे. तो वही बात हम करेंगे. आइए, आपको ये स्ट्रिप नजर आ रही है जो कि इस रीजन में एंटर हो रही है और मीट कर रही है सबसे पहले इस कर्व को जिसकी इक्वेशन y इज इक्वल टू एक्स स्क्वायर है, और इस रीजन को लीव कर रही है उस जगह पर, उस पॉइंट पर जहां पर ये स्ट्रिप और कर्व y इज इक्वल टू स्क्वायर रूट ऑफ x आपस में मिलते हैं. तो हमारी जो लिमिट्स y की हैं वो क्या हो जाएंगी, लोअर लिमिट जो होगी वो y इज इक्वल टू एक्स स्क्वायर, और जो अपर लिमिट जो होगी वो y इज इक्वल टू स्क्वायर रूट ऑफ x. और जहां तक x की लिमिट की बात है, आप देखिए इस स्ट्रिप्स को एक्सट्रीम फ्रॉम लेफ्ट से राइट की तरफ जाएं और रीजन में रहें तो x वेरी करेगा फ्रॉम 0 टू 1. तो ये हमारी लिमिट्स हो जाएंगी. सो आवर इंटीग्रल बिकम्स नाउ इंटीग्रल ऑफ x माइनस 2 with respect to y with respect to x, and y is from y is equal to x square to y is equal to square root of x, and x from x is equal to 0 to 1, and negative of all that because we have negative in our formula, and that is equal to negative of integration from x is equal to 0 to 1 x minus 2 into y, and the limits for y is equal to x square to y is equal to square root of x with respect to x. You can see that in this step we have integrated with respect to y, and here in this integral x minus 2 will play the role of constant, so integration of 1 will be y. So now substituting for the limits for y, we are getting what? That integral is equal to minus of integral x minus 2 into square root of x minus x square. These are after putting the limits for y. So this integral is respect to x, and the limits of x are from 0 to 1 and negative of that integral. So then it becomes negative of integral of x is equal to 0 to 1 of the function which is x raised to power 3 by 2 minus x cube minus 2 into x raised to power half plus 2x square, and this integral is with respect to x. Now integrating with respect to x, it is very easy. These are the polynomial. This is the polynomial in x. Just we have the powers, and we will be using the very well known power formula for integral. So that is equal to minus, just outside the bracket, 2 over 5 x raised to power 5 by 2 minus 1 over 5 x raised to power 4 minus 4 over 3 x raised to power 3 by 2 plus 2 over 3 x raised to power 3, and the limits are x is equal to 0 to x is equal to 1. After substituting these limit and calculating, we will get that is equal to 31 by 60. Please you do the calculations your own. ये हमने एक एग्जाम्पल स्टार्ट के लिए की ताकि आपको ग्रीन थ्योरम जो है वो दोबारा से याद आ जाए कि वो क्या थी, उसकी एक एग्जाम्पल की. अब एक और बात, खास केस है ग्रीन थ्योरम का, और ये भी बड़ा उसका इससे कोई एरिया मालूम करने के लिए, बाउंडेड रीजन का एरिया मालूम करने के लिए इस्तेमाल होता है. उसमें यह है कि P और Q अगर हमारे पास कोई खास हो, यानी P जो है वो सिंपल y हो और Q जो है वो माइनस x हो, तो ये इंटीग्रल क्या बनता है. आइए देखिए. अब P जो है दैट इज y, सो partial derivative of P with respect to y will be equal to 1, and Q is minus x. So the partial derivative of minus x with respect to x is equal to minus 1. And we substitute in the Green theorem, then the double integral of minus 1 with respect to x with respect to y over the region R is equal to minus of integral, that is y into dx, and minus x into dy over the that is closed curve C, that which is bounding that region. Now the left hand side becomes twice of integral of dx dy over the region R, and the right hand side integral becomes, that is equal to integral over the closed curve C of x dy minus dx. Left hand side, what is it? You can see that is only the area of the region. So therefore this area is equal to half of the line integral over the curve C of x dy minus y dx. Please note this result. So whenever P is equal to y and Q is equal to minus x, and if we integrate this around a closed curve C, then always we are getting the twice of area of that region bounded by that closed curve. So using this result, in fact, we can find the area of the closed region which is bounded by some closed curve. So let us do some examples that to find the area of some closed regions. Let us do that. Example 1. Determine the area of the figure enclosed by y is equal to 3x square and y is equal to 6x. As usual, first of all we will trace the diagram for this example. So we have y is equal to 3x square, which is a parabola, and y is equal to 6x, which is a line. Solving them simultaneously, these curve will meet at the point 0, 0 and at the point 2, 12. So the area of this closed region, you can see from the diagram, now will be half of line integral of x dy minus y dx around the closed curve C. So we will now integrating this line integral to find the area of this closed region. This closed region has two branches for their curves. Number 1, we call it C1, which is along the parabola y is equal to 3x square, and then from the point A to 0 along the line y is equal to, that is 6x. So therefore twice of area of this region is equal to line integral of x dy minus y dx along the curve C1 plus line integral of x dy minus y dx along the curve C2. We will integrate these two integrals separately. So first of all, along the curve C1, which is y is equal to 3x square, and therefore dy is equal to 6x dx, replacing dy by 6x dx and y by 3x square. The first integral, we say it I1 becomes, that is equal to integral of 6x square dx minus 3x square dx. X is from 0 to 2. The limits you can see from the diagram that x is varying from 0 to 2. So this becomes, that is equal to integral of 3x square dx from x is equal to 0 to 2, and the integration is very easy, that is x cube, and limits are x is equal to 0 to x is equal to 2. After substituting these limits, the result, that is I1, is equal to 8. I1, I mean the first integral which we have done along the path C1, along the curve C1. For the curve C2, y is equal to 6x, so therefore dy is equal to 6 dx. Replacing these in the integrand, we are getting now I2 is equal to integral of 6x dx minus 6x dx, and x is from x is equal to 2 to x is equal to 0. Please note, now we are coming from A, the point A, to the origin. So therefore our variation of x is from 2 to 0. This integral becomes 0. It is very obvious. So therefore our total integral is equal to I1 plus I2, that is 8 plus 0 is equal to 8. Now that was twice of area, and therefore the exact area is equal to half of 8, and that is equal to 4 square units. We have done an example to apply this result, which is a special form of the Green theorem, to find the area, and we will do another example, one more example on this topic. Let us do the next example. That is, determine the area bounded by the curve y is equal to 2x cube plus y is equal to x cube plus 1, and x is equal to 0, that is y-axis, for x is greater and equal to 0. As usual, first of all, we will trace the diagram. We have the curve whose equation is y is equal to 2x cube, which passes through the origin, and the other curve whose equation is y is equal to x cube plus 1, whose y-intercept is equal to 1. And the point of intersection of these curves, we can get those by solving them simultaneously. So eliminating y, we will be getting 2x cube is equal to x cube plus 1, and from here x cube is equal to 1. So the real root of x cube is equal to 1 is 1. So x is equal to 1, and then corresponding y will be equal to 2. So the point of intersection will be 1, 2. Also we have a other side of this closed region, that is along the y-axis. The equation of that is x is equal to 0. Let us see on the screen what I am telling to you. You can see here that the curve C1 is y is equal to 2x cube, and the curve C2 is y is equal to x cube plus 1. These two curves are meeting at the point A, whose coordinates are 1, 2. X is equal to 1, y is equal to 2. And for the second curve, if we put x is equal to 0, so y is equal to 1. So it meets the y-axis at the point B, where y is equal to 1, x is equal to 0. We have this closed region which is bounded by these three curves, the one that is C1, the other C2, and the third C3. C1 along this equation, whose equation is y is equal to 2x cube, and C2 whose equation is y is equal to x cube plus 1, and C3 along whose equation along the line whose equation is x is equal to 0 because it is along the y-axis. This is we have taken them in anti-clockwise direction, and we will integrate now what integration of x dy minus y dx about this closed curve, that will give us the twice of area bounded by these closed curve. So we will be getting the twice of area of that region. So first of all, along the curve C1, we will go from O to A along this curve C1 whose equation is y is equal to 2x cube. So from y is equal to 2x cube, dy is equal to 6x square dx. If we say this integral I1, then I1 is equal to integral of x dy minus y dx along this curve C1, and which is easy, and that is equal to integral of 6x cube dx minus 2x cube dx. Here we have replaced dy by 6x square dx and y by 2x cube. And ultimately this integral is equal to integral of 4x cube with respect to x is from 0 to 1. And integral of 4x cube is very easy, that is x is to power 4, and after substituting these limit x is equal to 0, lower limit x is equal to 1, upper limit, the result is equal to 1. So this integral I1 is equal to 1. Now along the curve whose equation is y is equal to x cube plus 1 from the point A to B. Here y is equal to x cube plus 1, so therefore dy is equal to 3x square dx, and we will replace in our integral y by x cube plus 1 and dy by 3x square dx. So our integral now becomes, that is we call it I2, that is integral of 3x cube dx minus of x cube plus 1 dx, and limits for x are from 1 to 0. Please note we are going from A to the point B. So the variation of x is from x is equal to 1 to 0. So that is the integral of 2x cube minus 1 with respect to x from x is equal to 1 to 0, and that is equal to x is to power 4 divided by 2 minus x is equal to 1 to 0. After substituting these limit and doing the calculation, we get this integral is equal to 1 by 2. Now for the third route, that is along C3, which is along y-axis. So what happens here? What is the equation of y-axis? That is x is equal to 0. So therefore x is equal to 0 and dx is equal to 0. And if we substitute in x dy minus y dx, everything becomes 0. So this integral is equal to 0. So the twice of area of this region is equal to I1 plus I2 plus I3, that is equal to 1 plus 1 by 2 plus 0, and that is 1 and half, and therefore A is equal to half of that, which is equal to 3 by 4 square units. Dear students, इस टॉपिक को वाइंड अप करने के लिए अब हम एक समरी करते हैं कि जो हमने लाइन इंटीग्रल के लिए और ग्रीन थ्योरम के लिए पढ़ा उसको हम समराइज करते हैं. ये बात हम आपको लिख के देते हैं पॉइंट्स के साथ, और इसको आप अपने रिकॉर्ड में रखिएगा. लेट अस डू दैट. Properties of line integrals. Sign of line integral is reversed when the direction of integration along the path is reversed. Path of integration parallel to y-axis. Then dx is equal to 0, and therefore integral is equal to only integral of q with respect to y along that path. If the path of integration is parallel to x-axis, in that case dy is equal to 0, and now the integral is equal to only the integral of p with respect to x along that path. Path of integration must be continuous and single valued. Dependence of line integral on path of integration. In general, the value of the line integral depends upon the particular path of integration. Now about exact differentials. If p dx plus q dy is an exact differential, then partial derivative of p with respect to y is equal to partial derivative of q with respect to x. And in this case, the integral of this p dx plus q dy is independent of the path of integration. And if the curve is closed, then the integration of this around this closed path is always equal to 0. Exact differentials in three variables. If p dx plus q dy plus r dw is an exact differential, then partial derivative of p with respect to y is equal to partial derivative of q with respect to x, and partial derivative of p with respect to w is equal to partial derivative of r with respect to x, and partial derivative of r with respect to y is equal to partial derivative of q with respect to with respect to w. And in this case, the integral of p dx plus q dy plus r dw is independent of the path of integration. And if the curve is closed, is loop, then this integration is 0. Now about the Green theorem. Green theorem says that integration of p dx plus q dy along a closed curve C is equal to negative of the double integral of partial derivative of p with respect to y minus partial derivative of q with respect to x, and that is over the region R. And for a simple closed curve, the integration of x dy minus y dx along the closed curve C is equal to twice of double integral dx dy over the region R enclosed by that curve, and that is equal to twice of the area of that region. Dear students, इससे पहले कि हम अपना अगला टॉपिक शुरू करें, हम कुछ बात फिर से वेक्टर्स पर करना चाहेंगे. आपने देखा होगा कि इस कोर्स में कई दफ़ा हमने वेक्टर्स जहां ज़रूरत पड़ी तो वेक्टर्स पर बात की, वेक्टर्स को पढ़ा. ये लाइन इंटीग्रल शुरू करने से पहले हम वेक्टर्स पे ही बात कर रहे थे, और उसमें ये था कि हमारा फंक्शन जो है वो डिपेंड कर रहा था वेक्टर्स पर, और वेक्टर वैल्यूड फंक्शन की बात कर रहे थे कि, और इसकी ज्योमेट्री भी ऐसे ही थी कि अगर हमारे पास कोई स्पेस में कोई पॉइंट है तो उसको हम डिनोट कर सकते हैं, उसको मालूम कर सकते हैं अगर हमें उसका पोजीशन वेक्टर मालूम हो. और इस पोजीशन वेक्टर के बदलने से हमारे पॉइंट्स जो है वो बदलते हैं, और इस तरीके से 2 डायमेंशन में और 3 डायमेंशन में कर्व जो है वो ट्रेस होते हैं. वेक्टर वैल्यूड फंक्शन की बात जब हमने की तो उसकी हमने डिफरेंशिएशन और इंटीग्रेशन भी की, जो कि आपको याद होगा कि वो कंपोनेंट वाइज थी. हमारा जो अगला टॉपिक है उसमें दोबारा से ये वेक्टर बड़ा रोल प्ले करेंगे और ये तमाम बातें जो आज तक हम पढ़ते रहे हैं वो हम वेक्टर को इस्तेमाल करते हुए करेंगे। कुछ बातें वेक्टर्स की जो कि हमने इससे पहले नहीं की, मैं वो आपके साथ शेयर करना चाहता हूं। सबसे पहली बात तो आप जानते हैं, याद कीजिए, ग्रेडियंट की बात हुई थी। अगर कोई स्केलर फंक्शन था तो उसका हमने ग्रेडियंट लिया था और उसके लेने के लिए हमने एक ऑपरेटर को इस्तेमाल किया था जिसको कि हम डेल कहते थे। लेट अस सी, डेल which is vector that is equal to ith component partial of partial x plus jth component partial of partial y and plus kth component partial of partial z। ये एक ऑपरेटर है और इसको हम अप्लाई करेंगे। इस ऑपरेटर को हम स्केलर फंक्शन पे भी अप्लाई करेंगे, इस ऑपरेटर को हम वेक्टर फंक्शन पे भी अप्लाई करेंगे और इसमें कई एक बात ये होगी कि जब वेक्टर को वेक्टर पे अप्लाई किया जाए तो उस वक्त या तो डॉट प्रोडक्ट हो सकती है या क्रॉस प्रोडक्ट हो सकती है। सबसे पहले हम अपनी पुरानी बात जिसको कि हम ग्रेडियंट ऑफ फंक्शन कहते थे उस पे आते हैं। फाई एक स्केलर फंक्शन है, देन ग्रेड फाई विच इज इक्वल टू डेल फाई, सो विच इज इक्वल टू पार्शियल डेरिवेटिव ऑफ फाई विद रिस्पेक्ट टू एक्स, दैट इज ith कंपोनेंट, प्लस पार्शियल डेरिवेटिव ऑफ फाई विद रिस्पेक्ट टू वाई, दैट इज jth कंपोनेंट, plus partial derivative of phi with respect to z, and that is kth component। आप देख रहे हैं कि phi स्केलर है और ये जो डेल है ये एक ऑपरेटर है और वेक्टर किस्म का ऑपरेटर है और इसको जब हमने अप्लाई किया स्केलर फंक्शन पर तो जो रिजल्ट मिला वो वेक्टर है क्योंकि इसमें ith, jth और kth कंपोनेंट है। नेक्स्ट हम अपने इस ऑपरेटर को किसी वेक्टर पे अप्लाई करते हैं। सपोज कि हमारे पास a कोई वेक्टर है तो उस पे हम इसको डेल को अप्लाई करेंगे। अब क्योंकि दोनों वेक्टर होंगे तो सबसे पहले हम इसमें डॉट प्रोडक्ट करेंगे, यानी कि डेल डॉट ए, और इसको हम कहेंगे डाइवर्जेंस ऑफ द वेक्टर ए। सो प्लीज, डाइवर्जेंस ऑफ ए दैट इज इक्वल टू डेल डॉट ए। इफ द वेक्टर फंक्शन ए इज इक्वल टू a1i plus a2j plus a3k, where a1, a2, a3 are functions of x, y, z, then del dot a is equal to this operator which is a vector and multiplied by this vector a1i plus a2j plus a3k, and this is dot product, and you can easily calculate this thing is equal to partial derivative of a1 with respect to x plus partial derivative of a2 with respect to y and plus partial derivative of a3 with respect to z. We have just multiplied del and the vector a, and this multiplication is scalar multiplication del dot a. So that is the divergence of A. आप नोट कीजिए कि gradient of a scalar function is a vector quantity and divergence of a vector function is a scalar quantity. आइए हम कुछ एग्जाम्पल करते हैं कि गिवन ए वेक्टर टू फाइंड द डाइवर्जेंस ऑफ दैट वेक्टर. जहां तक किसी स्केलर फंक्शन का ग्रेडियंट मालूम करना है, ये आप बहुत ज्यादा पहले लेक्चरों में कर चुके हैं. लेट अस डू सम एग्जाम्पल फॉर डाइवर्जेंस. एग्जाम्पल, if A is the vector which is equal to x square yi minus x y z j plus y z square k, then divergence of A, which is equal to del dot A, will be equal to partial derivative of x square y with respect to x and minus partial derivative of x y z with respect to y plus partial derivative of y z square with respect to z. And if we find these partial derivatives, that is equal to 2xy minus xz plus 2yz. Let us do another example for divergence of a vector. In this example, the vector A is equal to 2x square y I minus 2xy square plus y cube j plus 3y square z square k, and for divergence of A we will find del dot A. So therefore del dot A will be partial derivative of ith component with respect to x and partial derivative of jth component with respect to y and partial derivative of kth component with respect to z, and the sum of all these. And if you do this, we will be getting that is equal to 4xy minus 2 into 2xy plus 3y square z plus 6y square z, and which is equal to 4xy minus 4xy minus 6y square z plus 6y square z, and which is equal to 0. इस वेक्टर का डाइवर्जेंस जो है वो 0 है. ऐसे वेक्टर को हम एक खास नाम देते हैं और उसको हम सोलेनॉइड कहते हैं. बहरहाल हम अब आगे चलते हैं कि हमारा जो ये ऑपरेटर है डेल, वेक्टर पे अप्लाई कर रहे थे. अब पहले इस सूरत में जो वेक्टर पे अप्लाई किया था उसकी हमने डॉट प्रोडक्ट ली थी. अब किसी वेक्टर पे अप्लाई करेंगे तो उसकी क्रॉस प्रोडक्ट लेंगे. इसको यानी कि डेल क्रॉस into some vector, we will call it curl of that vector. So the curl of a vector is a vector because you know that the cross product of two vectors is a vector. So let us see on the screen what I mean. Here A is the vector that is equal to a1i plus a2j plus a3k, where a1, a2, a3 are the ith and jth and kth components of the vector. And now we are going to apply del on A by cross product. So we are going to find del cross A. We know that the vector product of two vectors can be easily expressed in determinant form. So here is this determinant, that is whose first row is I j k and the second row is partial x, partial y, partial z, and the third row is a1, a2, a3. If we expand these determinants, we will be getting del cross A, whose ith component is partial derivative of A3 with respect to y minus partial derivative of A2 with respect to z, and the jth component is partial derivative of A1 with respect to z minus partial derivative of A3 with respect to x, and the kth component is partial derivative of a2 with respect to x minus partial derivative of a1 with respect to y. हमने कर्ल ऑफ ए वेक्टर डिफाइन किया जो कि एक वेक्टर क्वांटिटी है, और वो ऐसे हासिल होता है कि हम जो डेल ऑपरेटर है इसको क्रॉस प्रोडक्ट करें वेक्टर के साथ. आइए इस पर एक एग्जाम्पल करते हैं. एग्जाम्पल, द वेक्टर a is equal to y raised to power 4 minus x square z square, which is ith component, plus x square plus y square, which is jth component, minus x square y z, which is kth component. And we have to find the curl of this vector a, and the value of that at the point 1, 3, minus 2. I mean x is equal to 1, y is equal to 3, and z is equal to minus 2. As we know, curl of a is equal to del cross a, and we write this determinant, whose first row is I, j, k, the second row is partial x, partial y, partial z, and the third row are the components of the vector a, which are y raised to power 4 minus x square z square, x square plus y square, minus x square y z. And we expand this determinant, which we are getting the ith component is partial derivative of minus x square yz with respect to y minus partial derivative of x square plus y square with respect to z, and the jth component with negative, that is partial derivative of minus x square yz with respect to x minus partial derivative of y raised to power 4 minus x square z square with respect to z, and the kth component is partial derivative of x square plus y square with respect to x minus partial derivative of y raised to power 4 minus x square z square with respect to y. We find these partial derivatives, and our result is a vector which is del cross a, whose ith component is minus x square z, and whose jth component is minus 2xyz plus 2x square z with the negative sign, and the kth component is 2x minus 4y cube. Now we have to find the curl of this at the point where x is equal to 1, y is equal to 3, z is equal to minus 2. We put these values and get this del cross a is equal to, and that is equal to 2i minus 8j minus 106k. सो आपने देखा कि हम ग्रेड लेते हैं एक स्केलर फंक्शन का जो कि वेक्टर फंक्शन मिलता है जिससे, और डाइवर्जेंस लेते हैं एक वेक्टर फंक्शन का जिससे कि हमें स्केलर क्वांटिटी हासिल होती है, और कर लेते हैं वेक्टर फंक्शन का जिससे कि हमें वेक्टर क्वांटिटी हासिल होती है. मल्टीपल ऑपरेशन इन ऑपरेटर्स की ये भी हम कर सकते हैं. मेरा कहने का मकसद ये है कि अगर आप डाइवर्जेंस किसी वेक्टर की ले लें तो वो स्केलर क्वांटिटी बन जाता है, तो लिहाजा उसका हम ग्रेडियंट ले सकते हैं, ग्रेड ले सकते हैं. और इसी तरीके से पहले अगर हम ग्रेड ले लें किसी स्केलर फंक्शन का तो वो वेक्टर क्वांटिटी बन जाता है, तो यहां हम उसका डाइवर्जेंस ले सकते हैं. और इसी तरीके से कर्ल ऑफ वेक्टर है, तो क्योंकि वेक्टर है तो उसका अगेन हम कर ले सकते हैं, तो कर्ल ऑफ वेक्टर भी ये भी पॉसिबल है, और उसका जवाब फिर से हमारे पास क्या आएगा, वेक्टर आएगा. आइए ये कुछ मल्टीपल ऑपरेशन हम करते हैं. इसमें हमारी जो पहली एग्जाम्पल है दैट इज वी हैव ए वेक्टर एक्स स्क्वायर वाई आई प्लस वाई जेड क्यूब जे माइनस जेड एक्स क्यूब के. इस वेक्टर का पहले हम डाइवर्जेंस मालूम करते हैं, यानी कि डेल डॉट ए मालूम करते हैं, और ये बड़ा आसान होता है कि इसमें हम ith कंपोनेंट का पार्शियल डेरिवेटिव रिस्पेक्ट टू x और jth कंपोनेंट का पार्शियल डेरिवेटिव रिस्पेक्ट टू y और kth कंपोनेंट का पार्शियल डेरिवेटिव रिस्पेक्ट टू z लेते हैं और इनको आपस में ऐड करते हैं. सो ये बड़ा इजी है. सो दैट इज इक्वल टू 2xy प्लस z क्यूब प्लस x क्यूब. Now that is a scalar function, and now we can talk about the gradient of this scalar function. So the gradient of divergence of A is equal to del of del dot A, and that is partial derivative of this function with respect to x will be the ith component, and partial derivative of this scalar function with respect to y will be the jth component, and partial derivative of this function with respect to z will be the kth component, and therefore this is equal to 2y plus 3x square ith component, 2x jth component, and 3z square k, that is kth component. And now an example for which we will find the gradient of a vector function, and then we will find its divergence. We have a scalar function phi which is equal to xyz minus 2y square z plus x square z square, and we are going to find the divergence of grade 5 at the point 2, 4, 1. So first of all, we are going to find the gradient of that, and that gradient is equal to how that is partial derivative of the function with respect to x will be the ith component, and partial derivative of the function with respect to y will be the jth component, and partial derivative of the function with respect to z will be the kth component, where this function phi is, we know that is xyz minus 2y square z plus x square z square. So applying this, so we are getting grade of 5, that is a vector quantity whose ith component is yz plus 2xz square, and the jth component is xz minus 4yz, and the kth component is xy minus 2y square plus 2x square z. प्लीज़ मैं ये जल्दी जल्दी कर रहा हूँ क्योंकि आप इसको अपनी फुर्सत में इसके तमाम ये पार्शियल डेरिवेटिव्स मालूम करेंगे विद रिस्पेक्ट टू एक्स पूरे फंक्शन के, और विद रिस्पेक्ट टू वाई पूरे फंक्शन के, और रिस्पेक्ट टू जेड पूरे फंक्शन के, और इस तरीके से आपको ये आईएथ और जीएथ और केथ कंपोनेंट इस वेक्टर का हासिल होगा जो कि हमारा ग्रेड 5 है. अब ग्रेड 5 चूंकि ये वेक्टर है, हम इसका डाइवर्जेंस ले सकते हैं. डाइवर्जेंस मीन कि इस वेक्टर की डॉट प्रोडक्ट लेंगे विद डेल ऑपरेटर. सो डाइवर्जेंस ग्रेड 5 इज इक्वल टू डेल डॉट डेल 5, एंड दैट इज हम अपने उस जो ऑपरेटर है उसकी डॉट प्रोडक्ट वहां उससे करेंगे. सो दैट विल बी जस्ट द पार्शियल डेरिवेटिव ऑफ द ith component plus the partial derivative of the jth component plus the partial derivative of the kth component, and that is equal to 2z square minus 4z plus 2x square. And now the value of this at the point, given point, x is equal to 2, y is equal to 4, and z is equal to 1. So that is equal to 2 minus 4 plus 8, and that is equal to 6. In fact, this del dot del phi can be written as del square 5, and that is equal to the second order partial derivative of the function phi with respect to x plus the second order partial derivative of the function phi with respect to y, and plus second order partial derivative of the function phi with respect to z. अब हम एक एग्जांपल करते हैं जिसमें कर्ल ऑफ कर्ल मालूम करेंगे, यानी कि वेक्टर होगा जिसका कि कर्ल मालूम करेंगे, उसका रिजल्ट फिर वेक्टर होगा, उसका फिर कर्ल मालूम करेंगे. Let us do that example. We have a vector function f that is x square y z I plus x y z square j plus y square z k, and we find the curl of this. We write the determinant as you know, and expand this determinant, getting the result that is equal to 2yz minus 2xyz ith component plus x square yj, that is jth component, and yz square minus x square z, that is kth component. Again we have this vector and we are going to find the curl of this. Again we are writing the determinant, that is I, j, k, and the second line with this operator, and the third line the components of the vector, and expanding and solving this determinant, we will be getting z square I minus into minus 2xz minus 2y plus 2xy j plus 2xy minus 2z plus 2xz k. And if we want to find the value of this at the point say 2, 1, 1, then the value will be this vector, which is I plus 2j plus 6k. Please do the detail of the calculation yourself. ये प्लीज़ हमने बहुत सारे ये कम्बिनेशन किए और कुछ काम हम आप पे छोड़ते हैं. बड़ा इंटरेस्टिंग है कि अगर आप डाइवर्जेंस ऑफ कर्ल मालूम करें, यानी कोई वेक्टर दे रखा हो उसका पहले कर्ल मालूम करें और फिर डाइवर्जेंस मालूम करें, ये ऑलवेज जो है वो ज़ीरो होता है. और इसी तरीके से कर्ल ऑफ ग्रेड मालूम करें, यानी कि पहले कोई हमारे पास स्केलर फंक्शन है उसका ग्रेड मालूम करें तो वो वेक्टर मिल जाएगा, और फिर उसका कर्ल मालूम करें. तो ये आप देखेंगे कि कोई सा भी एग्जाम्पल लें, इनफैक्ट इट कैन बी प्रूव्ड इन जनरल दैट दिस इज that is curl of grade that is always equal to 0. हम अपना ये लेक्चर जो है आज इस जगह पर ख़त्म करते हैं. असल में हमने ये जो वेक्टर्स की मुख्तलिफ बातें की हैं वो अपने आने वाले टॉपिक्स के लिए हमने एक रॉ मटेरियल तैयार किया है. इन वेक्टर्स को और इन वेक्टर्स के इन आइडियाज़ को हम अपने आने वाले लेक्चर्स में इस्तेमाल करेंगे. तो इंशाअल्लाह ताला अगले लेक्चर में ये बातें होंगी आपके साथ. तो उस वक़्त तक खुदा हाफिज़.